Hello students, welcome to the subject of complex variable and partial differential equation. And as you all know that in last lecture we discussed about second and higher order partial differential equation. Myself Ankit Acharya. So let's see, this is our second lecture. Let's take a quick revision of our first lecture. Okay, in first lecture I just explained about concept of homogeneous linear partial differential equation with constant coefficient. So this is our definition. Okay, after that we assume del by del x that is equal to capital D and del by del y that is equal to capital D value. Okay, put this two value in equation number 1. So we get this equation f of d d dash into z that is equal to f of xy, and f of d d dash is nothing but a0 d raised to n plus a1 d raised to n minus 1 d dash plus a2 d raised to n minus 2 d dash square plus up to an d dash raised to n, right? So f of d d dash, the value of f of d d dash is this, and the general solution of above equation is given by complementary function plus particular integral. So just we discuss about how we can find the complementary function. Okay, and for that, from this equation, right, from this equation you can directly write our auxiliary equation from the equation of d and d dash. Just instead of d, take m. Instead of d dash, you don't need to consider d dash. Okay, forget about all the terms of d dash. Okay, only the terms of d dash, right? So a0 m raised to n plus a1 m raised to n minus 1 plus a2 m raised to n minus 2 up to an that is equal to 0. So this is my m is nothing but d by d dash. Okay, and this is my auxiliary equation. You have to find out all the roots of this auxiliary equation. Now for this auxiliary equation you will get m1 m2 up to mn, in general n roots. Okay, suppose you have third degree polynomial, then you have 3 roots. Suppose you have fourth degree polynomial, then you have 4th root. Okay, so this is my case 1. If the roots of auxiliary equation are different, then complementary function is what? f1 y plus m1x plus f2 y plus m2x up to fn y plus mnx. Okay, if two roots are equal m1 and m2, so if two roots are equal m1 and m2, then complementary function is nothing but f1 y plus m1x plus x into f2 y plus m1x. Okay, so if two roots are equal, then we have to follow this rule. Other roots are distinct, different, so we can write as it is. If three roots are equal m1, m2 and m3, then complementary function I can write f1 y plus m1x plus x into f2 y plus m1x plus x square into f3 y plus m1x and so on. Other roots are distinct, so plus up to fn y plus mnx. Okay, and if you remember, just we solve our first example, del square z by del x square that is equal to z. That example we already solved in our last lecture. So let's solve this example, next example. Okay, del square z by del x square minus del square z by del x del y minus 6 del square z by del y square that is equal to 0. So if you want to write the equation of f of d d dash, okay, f of d d dash that is equal to del square z by del x square. So this is d square. Now del square z by del x del y. So I can write d into d dash, okay, and minus 6 del square z by del y square. So that is d dash square that is equal to 0. So this is the equation of d and d dash. Now what is my auxiliary equation? As I told you, m square, instead of d just take m square minus m minus 6 that is equal to 0, and don't forget what is your m. The value of m is nothing but d by d dash. Okay, directly I can write, but value of m is d by d dash. Now easily you can simplify. This is second degree polynomial, so m square minus m minus 6 that is equal to 0. So we have, when we factorize this equation, we have m minus 3 into m plus 2 that is equal to 0. So what are the roots? Roots are 3 and minus 2. Roots are 3 and minus 2. So that's why I can write complementary function that is equal to f1 y plus 3x, okay, plus f2 y minus 2x. Okay, what is our rule? f1 y plus m1x plus f2 y plus m2x. Both are distinct roots. So that's why complementary function is f1 y plus 3x plus f2 y minus 2x. Now right hand side we have 0. Okay, we don't have any function of x and y. So particular integral is 0. Definitely particular integral is 0. So that's why I can write z is nothing but CF plus PI. So that's why Z is nothing but F1 y plus 3x plus F2 y minus 2x. Okay. So in today's lecture, we just solve our first example. Let's solve one more example. 25R minus 40S plus 16T, that is equal to 0. Now, these are the standard notation. What is R? R is nothing but del square Z by del X square. What is S? S is nothing but del square Z by del X del Y. And what is the T? T is nothing but del square Z by del Y square. So first write this equation in this form. 25 del square Z by del X square minus 40 S is nothing but del square Z by del X del Y plus 16 del square Z by del Y square, that is equal to 0. Okay, so this is my original equation. Now f of d dash, if you want to write, we know that d, capital D is nothing but del by del X and d dash is nothing but del by del Y. So f of d dash, I can write 25 d square minus 40 d into d dash, okay, plus 16 d dash square, that is equal to 0. Okay, and now from this equation I can write the equation of m, that is 25 m square. Instead of d, just take m, so 25 m square minus 40 m plus 16, that is equal to 0. Okay, clear? Now can you understand, this is our perfect square. Okay, so 25 m square minus 40 m plus 16, that is equal to 0. That can be written as 5m minus 4 whole square, that is equal to 0. Correct? Don't forget, m is nothing but d by d dash. So just write down in each and every example. Okay, mention the value of m is nothing but d by d dash. So 5m minus 4 whole square, that is equal to 0. So roots are 4 by 5 and 4 by 5. Okay, and roots are 4 by 5 and 4 by 5. So we have equal roots, right? And equal roots, what is our rule for to write complementary function? Complementary function, I can write f1 y plus m1x plus x into f2 y plus m1x. So that's why f1 y plus x into 4 by 5. So 4x by 5 plus x into f2 y plus 4x by 5. Right? So this is my complementary function. Now what is my function? Okay, right side we have function 0. So definitely here also particular integral is 0, right? Because right side we don't have any function of x and y. So particular integral is 0. So complementary function is nothing but z. So z is equal to, I can write f1 y plus 4x by 5 plus x into f2 y plus 4x by 5. Clear? Now let's solve one more example. D cube minus 4d square d dash plus 3d d dash square into z, that is equal to 0. So you can see that in this example already they give example in the form of d and d dash. So what is our f of d d dash? F of d d dash, that is equal to d cube minus 4 d square d dash plus 3d d dash square, that is equal to 0. Now d will be common, so I can write d square minus 4d d dash plus 3 d dash square, that is equal to 0. Now in the form of m, I can write m into m square minus 4m plus 3, that is equal to 0. Don't forget what is my m. M is nothing but d by d dash. Okay, so this equation I can simplify m into m minus 1 into m minus 3, that is equal to 0. So roots are 0, 1 and 3. Okay, 0, 1 and 3. all are distinct roots, so that's why I can write complementary function. Don't forget, I write once again, roots are 0, 1 and 3. So complementary function I can write f1 y plus 0 into x. Okay, what is our rule? F1 y plus m1 x plus f2 y plus m2 x, okay, plus f3 y plus m3x. So m1 is 0, so complementary function f1 y, m2 is 1, so f2 y plus x plus f3 y plus 3x. Okay, and here also particular integral is 0 because right side we have 0 function. Okay, so z is equal to cf plus pi, so cf is nothing, z is equal to f1 y plus f2 y plus x, okay, plus f3 y plus 3x. Clear? Okay, so in today's lecture we discuss about how we can find complementary function for homogeneous linear partial differential equation, and we solve 3 examples. All examples are very important, so try to understand very carefully and do more and more practice for this type of example, so you can easily understand and you can easily solve all this type of example in your examination. So thank you.